Thank you for coming. The end of the day. I appreciate it. Thanks. I'm Lynn Langit, and this is going to be a talk about teaching kids programming. But we're going to start off with a quiz. Are you guys ready for a quiz? It's just a short one, okay? Just go with me on this. Just go with me. All right. See the picture? It's just going to take a minute. It's going to be cool. Close your eyes. Everyone close your eyes. Close your eyes. Close your eyes. I've got mine open so I can see if yours are closed. Close your eyes. I want you to imagine a developer. Okay, think about a developer. Think about somebody who's a really good developer, solid developer, been developing for a really long time. Developer not only writes a lot of code, works with teams, leads teams, teaches new people. Keep those eyes closed. Keep those eyes closed. Imagine this developer. Developer also reaches beyond their team and works to educate the community. Talks at user groups, talks at conferences, writes books. Keep your eyes closed. Developer gets a job at Microsoft, gets very well known, travels all over the world, gets a show on MSDN. Open your eyes. It's me. That's me. Just saying, okay? Just saying. So some of you might know me from the time that I worked at Microsoft, which was quite a long time ago. It was 8 years ago now. I'm an independent architect working in Southern California. I do cloud and big data, but I also do something else. And I've been doing it since I worked at Microsoft, which is teaching kids programming. I'm the director. So I like to start with the happy part. So I'm going to start with one of our great successes. This is our first graduate. I'm super proud of her, and I'm working to bring her here as a speaker next year. So if she comes, please come to her talk. She's 23 years old. Her name is Genevieve. She is now working for Pivotal as a developer in California. But her story is the story that I want to make happen for more people. I met her when she was 16. She had never done any programming. Introduced her to programming with my courseware, Teaching Kids Programming. She became enamored. She got inspired. She started teaching at 17 years old. She taught at the Worldwide Partner Conference for Microsoft. She keynoted a conference when she was 18 years old in Silicon Valley. She's really an exceptional person. At 19, she went to college in Canada. She went to McGill, and she had wanted to be a biology major to do cancer research, but she decided to minor in comp sci. She did original research as an undergraduate for breast cancer and has, successfully contributed to the field because she was able to do computational thinking, basically, in college. 21, she had an internship at Microsoft Research. At 23, she's a software engineer at Pivotal. She's our first graduate. Yeah, right? And I'm really working hard to bring her here next year. So that's the happy news. That's the happy news. We need more like that. So I'm going to tell you another story. Tell you a little bit about my story and why I started teaching kids programming and why I've spent 25% of my professional life for 9 years working on it and why I flew to Australia, basically. I don't like talking about myself, but I recently worked with some people to work on my speaking, and they suggested that I talk more personally. So this is really hard for me, but I'm doing it. You can see me peeking over my phone. So even though I live in California now, and I travel all over the world, I really had very humble beginnings. And I have to put a map because nobody knows where that is. I'm actually from West Fargo, North Dakota. No kidding. I'm the daughter of 2 farmers. My parents and no one in my family went to college. My dad went to the 6th grade. It was not not kind of life I'm having now. And really the reason I have the kind of life that I have now is because of education. So I have a personal lifelong commitment to doing what I can do to impact education because it changed my life. So it didn't start out really great. I was a really good student, and when I was 12, I was doing great in my geometry, and I said to my math teacher, Mr. Luna, Dwayne Luna, I said, what kind of career can I have? And he said, oh, honey, girls don't do math. And I went home, and my family said, yeah, he's right, honey, girls don't really do math. So I kind of stopped doing math. And apparently, my experience is not uncommon. We'll kind of come to that a little bit later in this talk. So, shortcut to now. I somehow did some math because I do data science and you need math for that. So I kind of want to give you a little bit about my perspective of now. I'm at the top of my career. I'm a successful big data and cloud architect. I travel all over the world. I am the only person in the world to have an MVP from Google, Microsoft, and Amazon, which is super fun and exciting. And how the heck did somebody from North Dakota do this? And how can we make this opportunity for more people? Well, one of the things that I've found in my world travels is that if I try to have a perspective of where I am and listen to local people and read local signs, talk to local guides, I can learn a lot. So you guys all know this, right? The stupid American tourists who walk into you on the sidewalk because we're walking on the wrong side and drive on the wrong side. Thank you for the look left. It helps me. It helps me to not die in Australia. I appreciate it. Okay. So I want to be that guide for all of you who care. Because you obviously care. You wouldn't be here at 5 o'clock in the afternoon in a conference when I'm going against Hanselman if you didn't care. So I appreciate the fact that you care. So I want to be your guide. Not that I'm the all-out expert. I've just been doing this for a while. So the first thing is I want to help you see things through my eyes. So this is at Google I/O 2 years ago. These are actual photos. I'm standing there. I took the picture. I'm a pretty, well, people call me a badass person, a tough person. But I actually was uncomfortable because if you got a good eye, you can see there's one other woman in the picture. But as far as the eye could see, there were no other women. No other women. And this is just 2 years ago. Well, all right, that's Google. Google, they're a bunch of engineers and, they're just San Francisco and, that's just the way it's going to be. It's Silicon Valley, right? This is ReInvent. This is the line to get into the Docker session at ReInvent. I did actually have a parting of the waters. I pulled my I'm an Amazon community hero card, but it was a very weird thing to say, do you guys know who Adrian Cockcroft is? The guy from Netflix? He's super famous. So he and I were hanging out at ReInvent, and we parted the waters, but it was just so odd. This is a social event in Los Angeles. This is a data scientist meetup. I was the keynote speaker the year before. Again, I think it's just really important for more of us to have this perspective, because I think that those of us who are underrepresented in the field aren't honest enough about it. It's really intimidating to walk into event after event after event like this. Really intimidating. So I figured, well, okay, it's less intimidating if you're the speaker, right? But is it? I mean, really, look, that's the big data camp in LA. That's another Google event. I mean, that's the thing that's really challenging for me. I know a lot of really great people have been working on this problem really hard for a lot of years. And that's actually why I started with Alan Kay. I met Alan Kay at an IEEE meeting in Southern California about 15 years ago. That guy is great, but he kicked the meeting organizers' butt because he said, whatever small thing you're doing, it's doing nothing. And sometimes I have to tell you I feel that way. And that's one of the reasons that I travel around the world and talk about teaching kids programming, because we need more people to work on this problem. So, bottom line, where is this happening? Where is it breaking? Middle school. Now, I'm not some researcher. I don't have reams and reams of data, but I do have resources on my sites to serious academic studies that show over and over and over that where not only women, but really anyone but mainstream or a very small subset of people fall off is in middle school. Falls off in middle school. And as organizations like code.org have started to make some impact with the younger kids, it's really exciting. I don't know how much they're doing here, but they're doing a lot in the US with the visual programming. It's fantastic. But what happens after visual programming? How do you go from visual programming to Java AP? You don't. That's what Teaching Kids Programming is trying to address. That middle area, when kids have gone to an event, they've gone to an event like the one we had here, got really excited, did some IoT, and then what? Computational thinking needs to be a core subject in school, period. Period. There are countries in the world that have started to recognize this, but not enough. And our teachers are struggling. I went to a teachers conference 2 weeks ago in California with one of my pilot teachers. Teachers are trying anything. They're looking online. They're trying because they know that our kids are getting behind. They need us. So I'm going to talk about what we've done in our organization, and maybe it will give you some inspiration, something you can do. They need us. So I started when I started at Microsoft. So something you can do if you work for a corporate is you can negotiate. I had 25% of my job responsibilities around this problem of access to coding on my review, my bonuses, so on and so forth. That's when I started. So that's my first tip for all of you that work in corporates. Go back and say, I want this to be part of my job. Not something I do on the weekends, not something I do on top of my regular job, something that you goal and metric me on. That was how Teaching Kids Programming started. Interestingly, do any of you recognize that last woman over there? Anybody recognize her? That would be Michelle. That's right. Who's here? Michelle Bustamante. This was 9 years ago when she was pregnant with her son. So it's a long-term journey. So yeah, it just happened that it was women developers. We had guys help too, but this was the first group. So Microsoft has a great program called DigiGirlz, and there wasn't one in Southern California when I joined. And so I said, okay, 25% of my job, I'm going to do this. So they sent me to ironically, to my hometown, to Fargo, North Dakota, where they're having DigiGirlz to see the program. And although it was well-intentioned, it was the worst thing ever. They had kids coding dynamics. They had no courseware for kids. They had lectures. It was just really bad. And it was very well-intentioned. But we needed courseware. So at that time, my daughter was 8. And I said, Samantha, let's find something that you like to do. And I'm sure some of you have done this with your kids already. Probably you're teaching your kids at home. That's a great way to start. Because that thing that your kid loves, that you love teaching your kid, kids at school will love that. The teacher will love that. It's a great way to start. She's out of Tech Ed, by the way. Starting off right, Tech Ed Orlando. So we started. I started, most DigiGirlz did 1 event per year. I ended up doing 7 events in Southern California, and then I traveled worldwide. So the curriculum that we wrote was used worldwide, and that's how Teaching Kids Programming started. It started with Small Basic, which was written by a Visual Studio developer. It's a version of Logo, basically, like the turtle, which this is not a new idea. This is the Samuel Popper stuff. Unfortunately just passed away, but it's visual programming. So a guy on the Visual Studio team wrote Small Basic, which still exists, and you can still use it. And we made a series of lessons and recipes for events. And it was used worldwide, taught hundreds and hundreds of kids all over the world. But in doing that, I started to understand that teaching an event wasn't going to be enough. Because what happens after the event, right? So when I left Microsoft, I worked with a group of open source developers. And in the US, if there's any programming offered at all in high school, it's Java. And I talked with a lot of teachers. And they said, we can't get kids to take these AP Java classes. They drop out, they don't like it, it's not fun, they don't have the background, they've had Scratch or Squeak, and then they leave. We need help. So I said, all right. So we took the work that we did in Small Basic, and we ported it to Java. We started and we had 13 lessons from our events, basically. That's how we started 5 years ago. Now, with some support from the nonprofit that we're part of, which is called the Mona Foundation, and a lot of volunteering from a lot of professional developers, we have a full year courseware library. We have 77 lessons. We have teacher training resources. We have a 100-page teacher training manual, and we have screencasts for teacher preparation. It's not great, it's not perfect, but it's being used. And all started from that first lesson that I did with my daughter, the first recipe. Everything's free. So the second takeaway or thing from my talk is you can use our stuff. Please use our stuff. I taught here for the kids' night last night or the other night, and there was one developer dad, and he's going to take it to his school. And I'm hoping to come back to Australia to do some more professional technical talks within the next year or so. And I would love to train school teachers. I would love to. So I'll offer myself. If you want to start looking at this, you want to start working with it, you like it, you want to bring it to your kids' school, I'm coming back to Australia. It's a great place. I like Australia. But I want to work with more of the schools. The targeted age range for this is 10 to 14, middle school, but it is also very applicable in high school in US. I don't know what is taught, if anything, in Australia in high school. But in US, with the AP Java, I have quite a few high school teachers that work with me and say they use it as almost a remedial to keep kids in. And you might say, Java, why Java? You should use Python, you should use R, you should use C#, you should use blah, 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 blah. Well, it's because of what's offered in US Java. I'm personally a huge fan of Python, and I have a version of TKP that I found that I haven't yet completed porting in Python in our GitHub repo. So if you're a Python person and you want to remote pair program or fork the repo, party on, great. If you're a data scientist, I found a complete version in R that I think is super cool, that I've used in some situations. The language actually really doesn't matter. It's more making curriculum that's fun for kids, that has some substance that teachers can use. So like I said, our stuff right now, we call it TKB Java. It's a bridge to AP CS Java. I'm going to show you it in just a minute. 40 hours of Java curriculum. The students start coding in 90 seconds, and TKP trained teachers can teach it. I'm having more and more STEM teachers, usually math teachers, teach themselves to code, and then ping me, and then we'll do Skype sessions to get them up and going, and then they'll start using it. That's usually where it's coming. Although I do have a history teacher I work with quite a lot who my daughter actually taught to code. It's kind of cool. So this is another happy thing. I had one of my first great successes this last year, a school district in Riverside, California. They're building a STEM program for 6th, 7th, and 8th. And in 8th, they selected the Java curriculum. And it's a really disadvantaged school district. Most of the kids speak English as a second language. Most of them speak Spanish. So the graduates, after they got all the way through, I challenged them to write a recipe. And they did, and then they had some other things happen, and they wrote me some letters. So this is one of the actual letters from a 10-year-old kid. Like, come on, you guys. That's all, he put line numbers too. Okay, like that's really cool. It's really cool. Ah, so good. So people ask me, because I did events for so many years, will you come do an event? Will you come do an event? Will you come do an event? And doing events is great, but I really see impacting this problem in two areas. Doing events to get people excited and motivated and kids realizing the possibilities, and then getting courseware in the schools. And very honestly, it's much easier to do an event than to go and train a teacher. It takes years. But we have to train the teachers, you guys. We have to. We have to. So right now we're working with very actively 4 school districts, and mostly over Skype, although I was going every single Wednesday for 4 years to my daughter's middle school and got some great feedback from that teacher. I work with a ton of nonprofits. We're the selected courseware for some boys and girls clubs and like all over the world, because I've traveled all over the world, some Sweden and Jordan and Brazil and all over the place. But I'm really, really moving the organization to move from events to schools, because we've got to normalize coding in schools. Now people say, well, do you have anything that's earlier? Well, in addition to the Scratch and Squeak, I did a bunch of work at Microsoft with Kodu. So if you are a Microsoft dev, if you have Windows laptops, it's Windows only. It's an awesome visual programming environment. I've done courses on it. It's super fun. There's a bunch of research around the fact that having visual computational thinking is more inclusive and gets more kids who would be like not as interested in some of the other programming mediums involved in it. If you happen to be on lynda.com, I have a lynda.com course on Kodu. We also did an experiment in C#, and that's on Pluralsight. So it's pluralsight.com/kids. It's the first lesson only. And the original source is on the Microsoft open source. What is that thing called? The old one that Sarah Ford used to work on. What is that one called? Codeplex. It's on Codeplex. So the original teaching extensions in C# are on Code. It's only one lesson though. And again, that'd be an awesome thing for somebody to do the tortoise basically on C#. But we do have the first lesson. And then on the older age group, a woman that we worked with for a while, Katrina Owen, who's really phenomenal. She has this site called Exorcism, which is actually great for pro devs too. It's basically a crowdsourced homework coding site where you do TDD. It's super fun. And just 15 languages. And she did some work with us and, you know, had her own ideas but got inspired. And so we kind of see working together. But we're focusing in the center. All right, so you're probably going like, okay, we're developers. What is she talking about? What does this look like? Well, let me show you some of the resources. So we have a website, and it's basically just an index into our stuff. So the courseware and the team and that kind of stuff. So we have 8 lessons, 8 courses. Each course has, you know, about 10 different recipes in it. And then inside of each course, and this is very much done for school teachers, we have one video to demonstrate the concepts. There's 1 to 3 programming concepts. And then we have a written lesson plan. So the lesson plan is on PenFlip, which is GitHub for writers. Kind of fun. It's all marked down. And it has, you know, this is very much for school teachers. This has been created based on what school teachers told me they needed. Like, how do I prepare? How do I set up? How am I ready? And it has all the answers. Then for all of us programmer people, this references into our GitHub repos. So we have an organizational repo. And for the Java, we have 2 sections. We have source, which, again, you're welcome to contribute to, fork, whatever. It's free. It's open. And then we have our teaching repo. Now, in addition to the lessons, the teaching repo just has the starter. The source has the starter and the solutions. And they're all indexed here. Like, here's the answers for the teachers, basically. So when the kids use it, they're going to just get the starter code. In addition to that, because we were inspired by the Small Basic editor, which was a simplified editor, we do a lot of customizations to Eclipse. And I'll show you what it looks like. We remove a lot of the menus. So we say press the play button. And we also do a whole bunch of things that make it easier to code correctly. So we, for example, add, if I say tortoise and I do a control space, notice we have custom Java docs for everything with a lot of icons and a lot of samples. So we have examples. Like, I've never written so much documentation in my life because we want to teach kids, you know, the best programming habits, right? Read your docs, because we all read our docs, right? Right? We all read our docs. And
we do read them when they show up right where the cursor is.
For sure, right? So we automatically put semicolons at the end. We automatically indent on save. So we've done a bunch of things so that kids can see the correct environment. Do you know what I mean? It's a set of custom extensions. So in addition to that, we have utilities for teachers. So one of the utilities that we have is something called our virtual proctor, and I'll show you how that works. What it is technically, since you guys are developers, this is a Google Cloud application that just captures a screenshot, generates a PNG on window close event, and sends it up to the Google Cloud, and then it just displays it with a little bit of metadata here so the teachers can self-select. And this is so that the teacher can have a sense of what the students are doing in the classroom, because our curriculum is Mastery-based. It's so conceptually similar to math, although I'm not a math teacher. What I find in working with math teachers is the same idea that everybody has to get through all the concepts in order to advance, and so the teachers need to have resources like this. So for each of the lessons, we have a core recipe, and then we do a concept called variation, which is refactoring. So what happens in the first recipe, we just do a square, and you can see the way that our lessons are written. I actually, by training, I did not major in computer science. I majored in linguistics. So we have a meta language that our team wrote that is, having English comments that are in a very has a similar style, so easier to read and consume. So, for example, we always have the verb, and the verb is always capitalized. So when I'm teaching this, I'll say, read line 1, and the kid will say, show the tortoise, and then I'll say, in English, we're starting with the verb, but in Java, we start with the noun. So what is the noun in the sentence? We use an interrogative-based teaching. Again, this isn't stuff we invented. This is the constructivist method of teaching that's been around for a really, really long time. We've just, I guess, applied it, if you will, to modern Java. So as we go along, we gradually make our API differ further and further from the English. So in this particular case, you have, show the tortoise, and then I would just have this move down. So and I have now done that. So I'd get rid of the comments, and then I would turn, so tortoise, control space. We teach keyboard shortcuts. And dot, and then we say in English you separate by a space, and in Java you separate by a period, and then turn, so type a T, and then control space, and then we would put this in, and then we would run it, and so on and so forth. But notice when we get to this one, change the pen color, the line the tortoise draws, to blue. Okay, we're programmers here. What's that going to be? There's no change. So what's it going to be? Anybody have any idea? Set. There's my programmer, set pen color. This is where we teach setters and getters, right? Set pen color. And then in terms of the colors, we had a lot of fun. And we overrode the Java default colors to be able to put a color picker. So we've done kidified things, if you will. We've also put a bunch of Easter eggs in the documentation, so that makes the kids read it and go, oh, what's going on? It's so fun, right? So it's fun. I mean, we have a great time. So then we have random colors. So then we, and this is the first lesson. So then the next thing we teach is the for loop. Even though now with functional programming, I'm having to rethink. Are for loops good? I'm not sure. But anyway, so we have the for loop, and we teach the for loop, and then we talk about how you have to move the mustaches down, because otherwise you're not going to have anything running. And then we have our for loop, and then we're going to go as fast as possible. And again, we purposely, Michelle, really? That's pretty funny. We purposely make this not the same as the English. So make the tortoise move as fast as possible. And I'll give you a hint. It's a set. So which one is it? Yay. Look at this kid. Yay. Set speed. And how would you know what speed? You'd have to read the documentation. Yay. Set speed to 10. Right? So the first part of each lesson is guided. Then the second part is the refactoring. So what we do is we say, all right, because you guys know this, when you get done and you code up your thing and you present it to your boss always says, well, you've perfectly understood the requirements and you're done and I'm happy to pay you now, right? right? So we're teaching the real world. So then we in each lesson, but this is the first lesson, we would then say to the kids, okay, if this square was the wrong size, which line of code would make it bigger or smaller? Who knows? How would you make this square bigger, let's say? Which line of code? Turn. Well, is it turn or is there another one? You want to make a bigger square. Move, right? Because that's how long the line is, right? So now let's see if it works. It did work. Now, what if we wanted to make a triangle? This is tricky because what sets the number of sides? How many sides are there? 4. So which line do you see the number 4 on? Right here, good, right. But sometimes code isn't easy to change, as we programmers know. So if we turn in a circle, that's 4 times 90. So we can just do 360 divided by 4, which doesn't change the behavior of our code yet. However, if we now want to make a triangle, we right-click and we refactor and we extract a local variable called sides. And yes, we teach this to 10-year-olds. And now, if we change the 4 to a 3, we will have a triangle. I love when I go to schools and I have 10-year-olds that say, no, Miss Lynn, it's refactor. No, Miss Lynn, you have to refactor that. It makes me so happy. It makes me so happy. So you'll see in each of the sections we have a number of recipes that reinforce. So we have a core recipe, and then we have up to 3 additional recipes. We also have a concept called a quiz. So I worked for a number of years as a Microsoft certified trainer, and I taught C# and different languages and so on and so forth. And let me just open this up. And what I always thought was really stupid was when I did the certification exams, that they were paper, sort of. You know what I mean? Like you had to answer on a piece of paper how to code things. Shouldn't you demonstrate that you know how to code by coding? What a novel concept, right? So we have quizzes, and the quizzes aren't so much for the teachers as they're for the students, because the way that we advise the teachers to facilitate them is, we always have the students work in pairs, by the way. Pair programming is integral to our teaching methodology, which I'll cover a bit more in a minute, is we say, okay, run the quiz, and of course we're going to fail because we haven't done anything. So we failed. Then go to each question and get it to work. Now, I was just, well, I'll be giving it away if I say where I was. What kind of thinking is it to write a line of code and then verify it? That's right. Our courseware has a test-driven development aspect written into it, that we have leveled it so as much as possible, 1 line of English is 1 line of code. So move the tortoise 110 pixels. What's the noun, people? Tortoise. So I'm going to type T-O-R, right, and control space. What would be the verb? Move. So I'm typing an N because I am using my tools. And then I should be typing what there? 110. I've got someone paying attention. I'm very happy. So now I will pass the first question. So when I talk about mastery-based learning, this is the part that's taken years. We've worked for years to level the courseware appropriately. And I got to tell you, honestly, that's the really hard part, right, from being a pro dev. Because we're out here coding every day. And you give it to the teachers, and they go, whoa, you've got too many concepts in there. We need to piece that apart. We need to add more recipes. We need to move these concepts over here and over here and over here. And that's been the real development of the library. Do you know what I mean? Because each course has 1 to 3 programming concepts. And there are 8 courses. Another thing that we have that's, I think, kind of innovative is we have katas. You guys heard of katas? Yeah. So katas come out of the Ruby community, although they're coming into more and more communities. And we run these as a mob. Heard of mob programming, group programming? I'll cover it back, but you work as a group, basically. So what happens here is, again, this is the sort of TDD style of thinking. They're called deep dives. So this is at the end of the module. The teacher will lead the group of kids. They'll sit in a circle. They'll put it on the projector. And the way that it works is it says right here, select the method name, then read the method name. Well, run it, and it's going to fail. And then fill in the blank. And oh, I have to put a blank back in here because it was. And for those of you that are wondering, the blanks are variable names. So kind of interesting implementation. And then change the blank and make the method pass. And then reflect on what you learned. And then rotate. So this comes, I mean, this is not anything we invented. This comes straight out of the Ruby community. We saw this at an Agile conference, room full of people, didn't know Ruby, teaching each other Ruby. And again, learn to code by coding. What a concept. So I'm going to go ahead and run this, and it's going to fail, of course, right? And then over here, I need to make that pass. So the method name is numbers do not need quotes. So what should I change this to? I think you guys can get this one. Guess. 42. Children are so smart. 42, I love it. Yes, yes. Okay, now what if you wanted to try putting quotes around this? Now it says numbers don't need quotes. Could you try that? Do you think it would work? How would you find out? Run it, right? Run it. Verify it. Nope. It was expected it to be an integer, but it was a string. So you can see that this is a very experimental kind of nature. It's actually kind of funny because the person who wrote a lot of these is my daughter. And a lot of them have teenager jokes in them, which I actually don't get. But when I teach it, or preteen jokes, the kids are like crying. They're laughing so hard. They're silly. They're silly, silly jokes. But we have all kinds, like this one goes into, this is just the first one, and then this one goes into a lot of the advanced for loop stuff. So in the bottom here we get, like this one. For loops can start anywhere, okay? So we can only change the underscore. Why is 7 the most feared number? You guys know this. Because 7, 8, 9. I know, teenage kids love it. Kids love it. So it's written for kids, right? It's written for kids. So anyway, so you kind of get a sense of what the library looks like. So I alluded to this, but this is actually integral and goes back to what I started with. And I'm as guilty as anybody else. People who go into programming love their computers. They love their machines. Many of us are introverts. Many of us are, you know, we like the logic, right? The logic. Isn't it beautiful? You go to work, you know, life is crazy or whatever, but by goodness, code is logical. So we aren't sometimes logical, but code is logical. But our industry needs to be more inclusive. It needs to look more like the world we live in. And in order to do that, we need to add ways of working with people into coding. And it's been really interesting because I've been dragged down this road. I was like, I'm never doing pair programming. That's stupid. I don't want to do it. I'm never doing mob programming. And I was wrong. The trick is, if you are introverted, you don't do it all the time. That's really what it comes down to. But you do it sometimes. You do it in situations maybe where you're learning or people are stuck or, you know, whatever. In fact, just as an aside, for the past 10 months, I have taken a contract that's 100% mobbing because I believe in pushing myself. And there have been days that I've loved it, and there have been days that I went home and said, I don't have enough wine in the house. Do you know what I mean? Because it's Node, and I got a headache, and oh. So it's that. Also, we want to normalize boys and girls coding together in school. I don't want to be negative about some of these events and some of these other things, because really anything that we do is going to help, okay? But I want it to be normal that boys and girls code together in school. Like, that is my dream. It's really important. So that's all the units we have. We go all the way up to TDD. The last lesson in our courseware is FizzBuzz. Seriously, we do FizzBuzz. It's awesome. We do FizzBuzz. It's so much fun. And we have all kinds of requests to go further. I have a huge request to do Android development. I have a request to do functional. I have requests to do all kinds of new courseware. I have spun off a separate nonprofit in our test location in the Boys and Girls Club. It's called TKB Labs. And we do really fun summer camps there to try things out. And Jessica Ellis, who runs that, is working with me to do IoT and data science curriculum. So we have a half-acre farm, and we've had a Java user group there for 3 years from where we started. And we now have IoT stuff going on a regular basis there. In fact, she's looking at doing some stuff with Azure and IoT. Also, the data visualization is unplugged. There's a whole bunch of unplugged stuff, which means without a computer. They put it on the wall. It's really cool. If you guys have ever heard of the guy David McCandless, he does Information is Beautiful. I met him at a SQL Pass conference, and we got very inspired by him, and we use his materials, and it's really, really pretty awesome. So we're doing stuff beyond the core, but my focus is core, because you got to have the core competency to do the fun, cool stuff. It's a discipline. You have to understand object properties and methods. You have to understand using your editor. You have to understand reading your documentation. You do. So there's one of my teacher colleagues. It's David Cooper-Smith. He's out in Riverside, and he is working with his teacher team to bring our curriculum to all of Riverside County, which would be like 40,000 students. So wish us luck. He wrote an NSF grant, and if we get it, it'll be like kind of our biggest launch in the United States. So really, really exciting. So I told you every course has all this stuff. We also have some paper worksheets for some of the teachers, so they have something to grade. So we really try to make it teacher friendly. So what kind of results? That's my daughter now, by the way. She's 17 now. She's a little younger there. She's been teaching. I dragged her in as kind of a helper in the beginning. She's been teaching since she was 12 years old. She taught a university class when she was 13. Right now, she's at Stanford. She's 17 years old, and she's taking data mining from a Googler. So this stuff works. It works. You teach your kid computational thinking, they go far. They do math. So I've personally trained over 4,000 students in, 9 years or whatever. I've personally trained 70 teachers. There's lots more. There's lots more because we're free. So I really operate on if somebody needs something, I will help them. I always tell people, if you are gone through the materials, you've learned them, you're stuck on something, you want to give me a feedback, you want to pair program on something, that is what Skype is for. And basically, I've devoted 25% of my professional life for 9 years to this, sometimes 50%, because it's just that important. It really is. So the other thing that is really interesting, and I started by talking about if you're in a corporate, because I know a lot of you guys are corporate, and you're probably thinking, well, maybe there's something I can do with my corporate. There is. So this is that same school. These are the graduates. I challenged them to write a Java recipe, because where I was working with the mob, they didn't know Java. And I said, if your kids, David, can write a Java recipe, I want them to come and have a field trip. And you can teach the programmers Java, and they will teach you JavaScript. And by God, we did it. And it was so freaking cool. So the kids came over. By the way, aren't those monitors awesome? That's where I work. 2 to 3 80-inch monitors, and we rotate. It's super cool. And there's David, and here's his kids teaching Java. And there's one of the professional programmers teaching JavaScript. And they broke into 6 mobs. One of the mobs, that kids finished the interview questions that they give to the professional programmers. And they were 12 years old. I was so happy. It was just wonderful. So again, this is maybe an inspiration of something you could do. You know, there's just all kinds of things you could do. If you're in a corporate, you could reach out to a school and give them a challenge. And if they meet the challenge, have them come. And not just walk around, code with you. Like that's the theme, hey? Code with you. Because they can do it. You'll be surprised. So many different ways that you can work with people. There's tons of nonprofits. You know, there's after school clubs. You guys have Coding Club here in Australia. I know that's been going really gangbusters. Going into the schools is fantastic. Working with your teachers side by side. Probably the most impactful thing to the library is this teacher we've been working with, who Samantha taught in her middle school for 4 years. The first year, I taught and she taught, and he sat in the class. The second year, he taught. This was 1 hour a week every Wednesday. And she helped, and I kind of observed. The third year, he taught on his own. The fourth year, he's written recipes for the library. It's pretty awesome, right? A history teacher has written Java recipes for the library. It takes a freaking long time, but it's worth it. It's worth it. It's worth it. So, I don't know what you're going to do when you go out of here, but please tell me you're going to do something, because there is so much work we need to do. Don't mean to end on a sad note, but I noticed something that came today that I wanted to kind of share with people. If you follow me on Twitter, there was an industry piece that came out of the advertising world that talked about a woman's experience. Oh, it looks like I got it. You guys must be tweeting about me. So this, and I'm not going to take the time in this presentation, but I'm going to personally ask every one of you to read this, because if you remember the pictures that I started with, without going into detail, I will tell you that I've personally had the type of experiences that are here, and I know many, many people in the industry have, and we are better than that. We are better than that. So if you'll do me that favor of reading that article, and you'll do me the favor of taking a look at the courseware that we have and maybe using it with your own kids or friends' kids, giving me feedback. I am not proud. I am not the greatest developer in the world. Anything you can tell me to make it better, I will hear. And let's make our world better, okay? And now we're gonna go have drinks with Michelle. Is good? All right, so I'm done. So hopefully you enjoyed it. And I'm done a little bit early, so I'm happy to take any questions, if you have any questions at all. Yes?
I have another here. You said that it is important to teach computational thinking, not coding.
Yes.
You said thinking. So what's that thinking?
What is computational thinking? That's a great question. So what I've done is, if I go into my pen flip here, as you can see, kind of laid out nicely. There are core concepts in object-oriented programming that kids need to understand. So what's an object? What's a property? What's a method? What's a for loop? What are the different types of loops? When do you do which loop? We still teach all those things that you had in college. We just try to make them fun. So what I mean by that is methods of performing computation that are common for the type of language. What I've really been noodling around, because I'm doing more and more big data stuff, is how to teach functional. That's like an area I'm very, very interested in. And should we be teaching kids functional? And should it be R or should it be IPython? You know, how are we going to prepare kids for, because I'm working on a course now on Hadoop VNext for Linda, so in Apache Spark, so in Scala. So how are we going to prepare kids for that world? Do you know what I mean? So to give a concise answer, computational thinking depends on the type of language. So what I see is there's OOP languages like Java and C++ and C#, And then there are less, looser languages like JavaScript and Python, and then there are functional languages. So there's 3 categories of languages. And again, I'm not an expert, I'm self-taught, right? And there are different programming paradigms that align with those languages. Does that make sense? Yeah. Okay, yes?
I would have thought that programming mobile phones would be really fun and exciting if you did that.
Yeah, well, I did work at Microsoft, so I was traumatized by the Windows Mobile experience. But I have had tons of requests for Android, and really it's a question of resourcing. Do you know what I mean? Because I may try to really grow my organization. We're kind of like a startup, and so the group that split off as TKP Labs, we were one organization, but they split off because they're more interested in events and they're more interested in farming and IoT and stuff like that. So once my daughter goes off to college, then I'm going to kind of regroup. So that may well come to pass because I know kids really like it. It's just figuring out what should be next. I mean, I really, should it be phones? Should it be functional? Because I work in big data, right? So I'm biased by that, right? So like one of the areas, for example, I'm really, really interested in, a friend of mine has cancer, and I am really, really interested in helping kids understand big data sets. And if there's something I could do around like genomic data sets. I'm actually talking with some people that are local to me to see if there's some kind of sample genomic data set or something. Like I tend to be, I have to be more fun. Like to me that's fun, but I don't know if that's gonna be fun for kids, right? So it's a question of priorities, so. Yes?
You spoke about how it's a struggle to get these types of things in. You've got not-for-profits and you've got small steps. Why isn't teaching kids programming a more mainstream subject, like arguably a more important subject than some of the traditional things taught at school?
Well, again, I'm not an expert, but my opinion is that when I first started, there wasn't awareness. It was seen as a niche area. It was seen as a specialty area. It was not seen as core. Now, because of efforts like code.org, code.org is really, really impacting US. They're actually going and changing laws in states to make computer science be allowed as part of the core curriculum. They are really, really making some significant change. I think that it's a generational thing because our generation, maybe my generation, I'm older than you, I don't know, we didn't have computers when we were kids, and so it's new, right? Whereas now, as we're aging, it's starting to be seen as this has to be part of it, right? So one thing as an aside, and I really didn't mention, but actually, since I have a minute, I want to call it out. This is really interesting. It was published today. Very, very interesting. I'm running up against this math phobia all the time. And just as an aside, I personally upped my game in math about 4 years ago. I was over 50 when I was laid up for a while. And what I did was I learned, like everybody else in the US or worldwide, from Salman Khan, I learned calculus when I was 51 years old. Right now I'm working on integrals because they didn't have it. And I love it. It's so awesome. Why didn't I learn this when I was younger? It's so fantastic. So it's just kind of an aside. I mean, it's a separate thing, but it does go to why isn't coding core? It's sort of this underlying thing. Why isn't extremely high math literacy core? Because by God, with all the data, we're going to have to, right? Like really. So I'm kind of on this bandwagon about all of us professionals need to up our math game. It's a way to stay relevant, and you study with your kids. And this is very interesting, came out today, and it showed a correlation. It's a study that shows a correlation because of the well-known situation of women not thinking they're competent unless they're 80% competent, and men thinking they're competent when they're like 30% competent. And I'm not being judgmental. This is statistically like studied, right? So what happens when the math gets hard is basically the women drop out. So, I mean, I think that I've kind of stumbled on reforming education, STEM education, but I can only do one thing at a time, right? You know what I mean? So to answer your question, I think that there are certain parts of education, and coding is a part, that are not seen as central. And I think that that is incorrect. Does it make sense? Yeah? Okay. I see back there. I've embarrassed many a developer at these kids' events who say, and I say, yeah, you unit test everything, don't you? And they're, yeah, yeah.
My question is, I've got teacher friends, and I think there's something coming through here in Australia as well about teaching kids to code, and they have a bit of anxiety because they're not technical people, and they're wondering how they're going to begin to do this stuff. Have you run into anything that, in your experience, how do we get the teachers passionate about this
Yeah.
as well?
So the things that are working are, I know this is going to sound really dumb, but when I worked with like 5 teachers to make this dumb little grid in the beginning of all this. This is the lesson plan, right? Because they just were like, I'm uncomfortable, this doesn't look like what I'm used to. I said, okay, show me a lesson plan. And this literally looks like what they have for a lesson plan, a little grid. And so it's like communicating with any other group that's new to you. You want to meet them where they are, right? So that's been a really big challenge. Like when we first started, we only had the GitHub, right? Because, hey, go to GitHub, get it, right? Teachers are like, what, right? So, and then we went through this website. Let's see, where's the website? Oh, I have to go here. So this website, basically you guys wouldn't need this. It's a fancy index. It's with pretty pictures, right? But the use of teaching kids programming went way up. And I did A/B testing with teachers, and I have teachers on the front page, and I spent hours and hours, agonizing over what, should I say, code or courses or blah. And I mean, it's still not perfect, okay, but it's this making the materials in a way that the teachers are comfortable with. Do you know what I mean? I mean, I still have a bunch of teachers, and one of the reasons I use this is because you can print it. They print everything. Teachers like printing everything, which is it's like, ugh, are you kidding me, right? But that's what they want. So taking the materials and making them, I think it's helpful that I have this background in linguistics, and I speak a bunch of foreign languages, and I've traveled all over the world. And, unlike many Americans, I have something broader than the, center of America view. Do you know what I mean? Well, it's true, hey? So it's like, okay, the teachers need this. Let me make the material in this format. So I'm constantly working to do that. Do you know what I mean? So that's number one. Number two is when you go and work with the teachers, it's really tricky in the beginning because they're experts at what they're experts in. Classroom control, managing the kids, that kind of stuff. And you're experts in coding. So being respectful, and if you're co-teaching with them, letting them manage the classroom and you guiding with the coding. Because it's really hard when you're the coding expert not to just take over. But co-teaching is really, really important. And then, like I did, in the school, just sitting down and letting the teacher teach and giving feedback after. Teachers are used to that, right? Like really going where they are. And I'll tell you, teachers are leery of programmer parents that come and tell them what to do. I understand. I have such respect for teachers. They don't get paid. They put up with bratty kids, crazy parents. I have reverence for teachers. I really do. So being respectful and giving them the materials the way they need. Does that make sense? Is that helpful? I don't know. So, okay, other questions? Go ahead.
So, you categorize the material by age group.
Yeah.
And I'm assuming that must be probably because of the age that certain mathematical skills are talking. So is there a way that we can sort of make sure that those mathematical skills are there irrespective of the age? Like, so to teach certain programming concept, you know, which requires certain mathematical skills.
Yeah.
Is there a way that we can sort of make sure?
There's no pre-test or anything like that. And so a couple things. I'll tell you a couple things that don't work, and this might be helpful. So we did, you guys know, do you have a concept of code camp where you have like a one-day thing locally and you kind of meet up at a university? So we did a bunch of code camps, and they were actually just horrible because what happened is people brought their kids and basically saw us as daycare. And we had kids from 6 to 17. And it was horrible. So one of the things is to try to get the age, that's why in school, to actually learn concepts, get the age close together, okay? That's one thing. Another thing is pair programming is really great, just like it is for adults. You know, you have people working together and you can be, and the teachers are really gonna be good at this, you can level out. Like if you have a really advanced person, they can be teaching a person who's remedial. Or you can have people that like working together, do you know? Because part of what we want to happen is people need to learn to work together, right? And the teachers are really down with that. So for this courseware, kids should know how to keyboard. So I'll give you an example of where it was a challenge. I was in Zambia, because I did some other work over there. And even though the kids were 12, they didn't know how to keyboard. And so what we did is we separated, well, most of them, we separated the kids who maybe had access to a laptop from the kids who didn't. We leveled them, basically, because it was too frustrating for the ones who have never done a keyboard before. So you kind of try to group people together. Do you know what I mean? So, and that's also why we have extra recipes, because if there's some really fast kids, they can do the extra recipes. So, yeah? Okay. What else? Yeah, back in the back. Oh, sorry. I didn't see you, sorry.
So I'm a parent of a 13-year-old daughter, so it's very relevant to me, and she's quite all right with math and everything. The challenge I have is she's not really into math, so she's not excited by her teachers or, you know, environment. So my question is, I guess, how to get her excited through the books. So I've read How Not to Be Wrong, The Power of Mathematical Thinking, which is a great book, but I don't think it's for 13-year-olds. So I'm looking, maybe you can have some sort of suggestion about to read something that is fun, and at the same time it gives the reason for learning math in life, because kids just don't get why do they need math.
So it's for kids who aren't grabbed by numbers, I find visualization. So this is that David McCandless person I was talking about. Here's his website, Information is Beautiful. So most kids care about something. So find out, you know, like, does she care about animals? Does she care about old people? Does she have a hobby? Something she cares about. And then represent mathematical information visually. And that will engage them. So let me try to find something here. This one's cool. The billion-dollar-ogram. Okay, this is more for adults, okay, but. So basically this is the visualization of money. And you can see like how much is spent on healthcare. I mean, it's neat, right? Like how much Apple makes, how much their profit is, right? And it's interactive. So there's a bunch of things in, that's the source data. There's a bunch of things in the New York Times. I don't know if any newspaper in Australia is doing it, that are interactive. Like they show the impact of global warming. They show the glaciers melting, and they show, you know, I think that would be interesting here, unfortunately. They show the oceans rising and, you know, things like that, right? I find a lot of times kids that say they don't care about math, they do care if it's related to, oftentimes seems to be nature. Like we were teaching in Hawaii, not a bad gig, right, on Molokai. Molokai, in case you don't know, some of you might, is where many of the indigenous Hawaiians live, and they had the leper colony and all this kind of stuff, and they're very anti-development. And so they have no jobs, right? And so this rich family from Molokai brought us there. And the kids were just like, we don't care. We don't care. We don't care. We don't care about this. Why would we care about this? So we actually use Kodu. We use visual programming. That's another thing you can do. And we had them make Molokai. We had to make the island. We had contests about what would be the ideal Molokai and what should Molokai look like. And in Kodu, they have a when do, and they have loops and stuff like that, but it's visual. So the sort of key thing is visual, some kind of visual computational thinking that connects to something that she cares about. Does it make sense? And I hope that's not too abstract, but yeah. Not books. It has to be hands-on. You have to do hands-on. Books aren't going to do it. Again, I'm a big data and cloud architect and a mom, okay? I am not an educational expert. I just have had some success with things. What we did with, how we did this in the lab is the kids grew herbs, and then they made pesto, and they made 4 different flavors of pesto. Like one was garlicky, one was lemony, whatever. Then they took it home, and they had to collect data on a sheet, and then we gave them like string and Post-its and paper, and then they had to visualize the results of the data. And they could also use like dried basil leaves and stuff like that. And it was the most fantastic thing. I mean, that was a mathematical thing, right? Because they had to quantify what flavors impacted the likability of the food. So, you know, making it tangible is really what makes it interesting, right? I think so. Okay, any other questions? Go ahead.
What sort of time commitment did you expect, I guess, from teachers when you first started?
Yeah, well, like when I was really first starting and I was very naive, I was like, oh, we'll do 40 hours and I'll go through the whole library, and nobody does that. So I just kind of take it as it goes. Like usually we start and I say, okay, do the first course, which has 7 lessons. And then I kind of see how the teacher does. And if I can physically go there, I'll go there. And that'll take them maybe 2 or 3 hours. But more often than not, I Skype. So I do a lot of 30-minute Skype sessions. 30-minute Skype sessions seem to work pretty well. So it varies by the teacher, you know. Because some, like math teachers, sometimes they're really good, you know. And especially this type of coding, it clicks in for them, right? Really fast. But then others, you know, really are needing more. I mean, I'll give you an example of something where we weren't successful. We went to an urban school district in New York City, Brooklyn, New York, and we had people who did not have any mathematical training. They were basically like office workers, and we were not able to support them because they needed to have, you know, 8 hours for 2 hours of courseware. So that was frustrating to us, but you have to be realistic, right? So consultant answer, it depends. Right?
So when you say sort of 3 hours or
Yeah.
half an hour,
Yeah.
you're talking weekly?
Mm-hmm.
Every week?
Yep. What else? Yes? Oh, hi.
At my school, I'm in grade 8, and for coding, we just use like code.org kind of stuff,
Mhm.
little blocks.
Yeah.
And we still do that in grade 9,
Mm-hmm.
but after that, we don't have any other coding lessons or anything else. Like, we just use the blocks. Like, what else is there?
That's what this is for, my dear. Thank you for asking that. I'm making it for you. So will you try it? Great. What's your name? Rollo? Okay. Okay. Well, let me know, okay? You can find me on the internet. Very easy to find. All right. Anything else? Or is it time to drink with Michelle? You guys are fantastic for hanging in. Thank you so much. I hope you found it valuable.